Hi everyone, welcome to YourPedia. This is Chandrasekhar. I'm a mentor at YourPedia. You all know that recently Airport Authority of India released its notification for various posts, right? So I am going to take up physics part. I'm going to take it up here. So one of the very important subject and scoring subject also. It's very easy. Physics is very easy, right? So this is for junior engineer examination, but soon ATC, Air Traffic Controller notification is about to release. And if you are very serious about that, this is the time you have to start your preparation. The reason is the syllabus for this examination at AAI ATC both are exactly same, only two extra topics, that's all in this exam. Only two extra topics are there, right? Apart from that, everything is same. So if you start your preparation, definitely that is going to be useful for you for your ATC preparation also. Next month for sure ATC notification is about to release, right? So in physics, one important topic where students, most of the students will feel it as very difficult, I'm going to take up here is current electricity. Yes, today's topic I'm going to take it up here. All this is advertisement and the syllabus and all these things, right? You might have been gone through this, right? Yeah, these are the number of posts and weightage and all these things are given here. You can get this document if you join our free WhatsApp group. Okay, we made a free WhatsApp group in which we are providing you free content, absolutely free content, right? Means syllabus and syllabus related content and formula tables and questions along with solutions. This way we are providing, right? It is very much useful. You can join our free WhatsApp group using the link that is given in the description box of this video, right? So our topic is alternating current, right? Our topic is alternating current, right? So let me discuss about the questions which were asked previously and some practice questions. Yes, the questions what I am discussing here are previous questions and practice questions, right? This is the previous question. In case of step up transformer, which option is correct? What is a step up transformer? Yes, let me explain you clearly. Step up transformer, right? Step up transformer. Yes, transformer. What this will do is this is going to increase the voltage. Yes, if you take up a transformer, yes, the transformer mainly is used for two purposes, either to increase the voltage or to decrease the voltage, right? So number of turns in the primary are N1, number of turns in the secondary are N2, and this is V1, this is V2, or this is V primary, this is V secondary. If you see in the diagram also, I show number of turns in the secondary part are more when compared to primary part, right? So number of turns are more, therefore induced EMF will be high or voltage is high. So here in this case, V secondary, in fact V secondary is greater than V primary. Now we are defining something called as K, that is equal to V secondary by V primary is going to be greater than 1. Yes, I want a step up transformer, that is which is going to step up the voltage. Yes, greater than 1. So from this one what we get is V secondary is greater than V primary. This is the simplest question I had ever seen, right? Yes, simplest question. Number of turns in the secondary are more than number of turns in the primary. In the same way, see, the transformation, that K is called as transformation ratio, that is equal to N2 by N1, number of turns in the secondary by number of turns in the primary, which is equal to V2 by V1. Yes, that is equal to, we named something new here, Vs by Vp, V secondary by V primary, that is equal to I1 by I2, or in the same way we can take it as I primary by I secondary. I secondary. K greater than 1 for step up transformer. For step up transformer. K is less than 1 for step down transformer. So K is less than 1 for step down transformer. K is exactly equal to 1 for 1:1 transformer, which is not required for this. In electrical engineering, people will study, or in electronics engineering, people will study about 1:1 transformer, or it is called as isolation transformer. We are not bothered about that, right? Either step up or step down. K is greater than 1, step up. K less than 1, step down, right? So in case of step up transformer, which option is correct? So here Vs is less than Vp, which is wrong, right? Here Rs is greater than Rp. Yes, Rs is greater than Rp. That is not Rs and Rp, that is Ns and Np. Yes, Ns and Np, right? Here this is not RS, this is NS is greater than NP. Here this is NS is less than NP, wrong. Transformer ratio, in fact it is called as a transformation ratio which is less than 1, not correct. Therefore option B is correct. Option B for Bombay is correct, right? The convention they've given wrong, that is NS it is, not RS, right? So R, if they are talking about resistances, primary resistance and secondary resistance, so that is fine, but it is not about resistances, right? It is about number of turns, right? Let's go to the second question. The average power, yes, the average power supplied to an inductor over one complete cycle is, do remember, yes, inductor and capacitor, average absorbed power, over a full cycle, over a full cycle is exactly equal to 0. Inductor and capacitor, if you take ideal elements, those elements does not absorb any power, okay? That's why that is exactly 0. Or sir, I need through the formula P is equal to VI cos phi, where cos phi is the angle between voltage and current. If I talk about inductor, L is a standard symbol which is used to represent the inductor. This is voltage V, this is current I. The angle between these two is exactly 90 degrees. In an ideal inductor, I repeat, in an ideal inductor, current lags behind the voltage by 90 degrees. In an ideal capacitor, if you take an ideal capacitor, this is voltage V. So this is going to be the current. This angle is 90 degrees. So P is equal to VI sin, so P is equal to here also VI cos phi. How much it is? 0. How much it is here? 0, because cos 90 is 0. In an ideal capacitor, current leads the voltage by 90 degrees, right? 0. The answer is 0. It means the same question is asked for capacitor, then also it is correct. It is 0. But in capacitor, current is going to be leading. In inductor, current is going to be lagging, right? Next question. A purely inductive or purely capacitive circuit, the phase difference between voltage and current is, just now we discussed, right, in the previous question, right? The phase difference between voltage and current is going to be plus or minus 90 degrees, or in terms of radians, it is plus or minus pi by 2 radians. Answer is pi by 2. Actually, it should be plus or minus, as they did not mention it. Only one option which is related to pi by 2 given. We are taking it as pi by 2. That's all. It's not pi. It's not pi by 4. It's not pi by 6. Right? Next, see. So these are the formulas table I provided for you to understand what it is happening exactly. Means if you take any AC quantity, suppose if you take voltage of V of t, any alternating quantity is represented with V of t is equal to S Vm sine omega t. V of t is equal to what? Vm sine omega t, right? If I sketch this waveform, yes, if I sketch this waveform, this is omega t. If I sketch this waveform, this is going to be this way, right? Yes, this is going to be this way, right? It continues. Yes, this is Vm. Yes, this is Vm. Yes, this is minus Vm. This is minus Vm. This is 0, pi. This is 2 pi, right? This is pi by 2. Yes, this is 3 pi by 2, and it continues, right? And it continues. Now this is having maximum value, which is also called as peak value. Maximum value or peak value, both are same. See, maximum value is Vm, which is also called as peak value. It is going to have something like RMS value. RMS means root mean square. Root mean square value will be Vm by root 2. Yes, that can be proved this way. What is VRMS formula is, yes, read in the reverse way, SMR, square it. What? Vm square sine square omega t, right? Then you mean it. Mean means average. Average means area by time, right? Area. Yes. What is the area? area formula is integration 0 to 2 pi, 0 to 2 pi by time is how much? Total 2 pi, right? Then you see root it to the total. If you're going to put the root, square root, you're going to get this value. You're going to get this value. Root mean square, or first you square it with respect to d of omega t. We do, yes, with you square it, then you mean it, then you root it. You're going to get Vm by root 2. See, if you're good at mathematics, simple mathematics, you'll get that. But only our motto is not to waste our valuable time in doing this calculation, right? Yes or not? Yes. How much is that value? 0.707 times of Vm. 1 by root 2 is 0.707, right? Now average value, if you talk about this full wave average will be 0. Full wave average value will be 0. Means if you consider average, means area by time. Average means area by time. If it is having positive area and equal amount of negative area, both will get cancelled, right? Full wave average is 0. If I take for half wave, then I have to take the time limit also from 0 to pi only, right? What is the formula for average? I am doing here. V average, any average is equal to area by time. Area means what? Integration. 0 to pi only we have to take. 0 to pi Vm sine omega t. So d of omega t by pi, right? If you do this, you're going to get 2 Vm by pi. How much it is? 2 Vm by pi. If you take for full wave, it is 0. Yes, for full wave it is 0. 2 Vm by pi. How much it is? 0.637 times of Vm. So it is always better to remember this value also, because 2 into Vm by 2 by pi in the examination, pi is 3.14, 2 divided by 3.14. Doing that calculation is a little hectic process. That's why I am asking you to remember that values also, which is better for you, right? For your preparation. Form factor. What is form factor? Form factor is also called as shape factor. Shape. Yes, it is also called as shape factor. What form factor tells us is form factor is equal to, yes, RMS value by average value. Let's take V RMS by V average value. This is the formula for form factor. What is RMS? We got Vm by root 2. What is the average? We got 2 Vm by pi. If you do this, you get it as 1.11. You get it as how much? 1.11, right? V RMS by V average. V RMS by V average. The next is peak factor or crest factor. Peak factor or crest factor. See, what is form factor? RMS by average. I repeat, RMS by average is form factor. What is the peak or crest factor? Vm by VRMS. V maximum by VRMS. How much it is? Vm is, you keep it as Vm only. VRMS is what? Vm by root 2. It is going to be root 2, 1.414. 1.414, right? Now, if you do this, you're going to get this one as 1.11. Wherever you see form factor as 1.11, that given signal, that given waveform is either sine or cosine. Yes, we understand this way, that is either sine or cosine, right? Let's go to the next table. See, in the AC, when you apply AC, this capacitor is going to behave like capacitor reactance of XC, which is equal to 1 by omega C. Omega is angular frequency, that is 2 pi, 1 by 2 pi FC, whose units are ohms, right? If you take inductor, if you apply AC means alternating. Alternating means what, sir? This is this Vm sin omega t kind of thing. Need not to be sin omega t, it may be cos omega t also. What is the very difference between sin and cos? Just a phase angle of 90 degrees, not more than that. The only difference between sin and cos is having phase angle difference of 90 degrees, right? Yes or not, all of you? Then that is about sine and cos. Now it may have some phase angle difference also. It may be sine of omega t plus some theta. It may have some theta, that doesn't matter. It may have some plus theta or minus theta. Theta may be positive or negative. It may be in any way. It may be in any way, right? So that is alternating voltage. If current voltage is alternating, obviously current is also going to be alternating, having some phase angle difference, right? Pure resistance. Now see, the combination of resistances, this is called as capacitive reactance. This is called as inductive reactance. XL is equal to omega L, which is equal to 2 pi FL, whose units are ohms. Now Z is the impedance, which is the combination of resistances and reactances, which is the combination of resistance and reactances, right? Pure resistance, Z is directly equal to R. Okay, no X term. Why? Because it is not having inductance or capacitance. Now for a resistance, if you apply voltage, current will be exactly in phase. Means if your voltage is Vm sin omega t, current will be Im sin omega t. No phase angle difference you are going to get. As I told you, for inductor, yes, current lags. This is V, this is I. Current is going to be downside. Current is lagging. This is for inductor. This is for resistor. For a capacitor, yes, this is voltage V, yes, this is current I, yes, this is 90 degrees, current leads. For yes, yes or not, yes, as I told you, you see XL is equal to omega L. These units are ohms. Inductive reactance and capacitive reactance are units of ohms. This is 90 degrees, this is 90 degrees, right? Now phase angle, voltage with respect to current. So here voltage with respect to current, voltage is having more angle compared to current, because current is lagging, that's why it is plus 90. Now here you see voltage leads current. Now if I mention it as minus 90, then I can write that current is lagging behind the voltage. Statements are simple, don't get confused. Okay, right? Now I wanted for series RL circuit. What is series RL circuit? If I take some resistance and reactance in series, this is R, this is XL, but it is having some phase angle difference. Z is equal to R plus JXL I have to write. R plus JXL. For resistance and capacitance, if I take R, this is going to be XC. Now Z is going to be R minus JXC. It is going to be R minus JXC. Do remember. Sir, what if I have R, L, C, all three? That also we'll see. R, L, and C. This is going to be XL. This is going to be XC. Then Z is equal to R plus JXL minus JXC. Now Z is equal to R plus, if I take J common, yes, what is that? XL minus XC. If I take J common, XL minus XC, right? Now as it is a complex number, you got the magnitude mod Z is equal to root of R square plus XL square, right? R square plus XC square, root of R square plus XL minus XC whole square. Now here phase angle phi is equal to tan inverse of imaginary by any complex number. If you have that, phase angle is equal to tan inverse of imaginary by real, tan inverse of imaginary by real, right? That way here XL minus XC by R, right? For series RLC, that this is very important table to understand, right? Next is resonant frequency. What is resonance? So resonance stands for, what is resonance? See, I'm teaching you to the point. I'm not going in depth of the concepts because the reason being here is for examination, this is what most important thing for us. Okay, directly formula based questions will be given, no deep logic. Why? Because this is 10 plus 2 level physics, right? 10 plus 2 level physics. So and this is a junior executive examination, right? So not too deep will be given, only superficial level of questions will be given, right? Even the toughest question in AAI exam is going to be very simple compared to IIT JE mains or advanced, right? Yes. Now resonant frequency. What is resonance? If this is going to happen in RLC circuit. Okay, if inductive reactance is exactly equal to capacitive reactance, then that situation is said to be resonance. What is inductive reactance? Omega L. What is this capacitive reactance? 1 by omega C. As that situation is called as resonance, omega R into L is equal to 1 by omega C, right? Omega R square is equal to 1 by LC. So omega R is equal to 1 by under root of LC radians per second, that is FR is equal to 1 by 2 pi, yes, under root of LC hertz. Yes, what is it is hertz, right? This is the formula, right? Now quality factor, what quality factor says is quality factor Q is equal to, see, energy stored by energy dissipated. I repeat, energy stored by energy dissipated. That will define the quality of a coil. quality of a coil or inductor or capacitor, whatever it is, right? If you're taking inductor, we are discussing about its quality. Its quality is going to depend upon how much energy it is storing, out of how much energy it is dissipating. Quality factor Q is equal to yes 1 by R into under root of L by C, which is equal to 1 by yes omega R into C, or 1 by omega RC, 1 by omega RC, yes 1 by omega RC. See, you see these are the formulas, that is equal to omega R into L by R, right? So all these three formulas. So this is for series RLC. This is also, if you have R and C values, this one. If you have L and C values, R and L values, this one is correct, right? Do remember those formulas. We can derive those formulas in very easy way, but derivations are not required for your examination. That is going to waste our valuable time. That's why I'm not taking derivations here. Our next question is about bandwidth. Bandwidth is nothing but upper cutoff frequency minus lower cutoff frequency, F2 minus F1, where F2 is upper cutoff frequency, F1 is lower cutoff frequency. That can be also written as resonant frequency by quality factor, FR by Q, right? So resonant frequency from I can say like half power frequencies. So this F2 is called as upper cutoff frequency, F1 is called as lower cutoff frequency. Those are also called as half power frequencies, F2 and F1. See, what does it mean by half power, sir? Now if I draw this way, now this is F1, now this is F2. Any frequency less than this will be neglected. So this is removed. Any frequency higher than this one is considered. Only this portion is considered. F2 minus F1 is considered. Means if you calculated F1 and F2, the power that is going to be absorbed is going to be half of the maximum power. So suppose this is the maximum value, half of the maximum power is going to be absorbed. That's why it is called as, those are called as F1 and F2 are called as half power frequencies, right? Now resonant frequency in terms of half power frequency is equal to under root of F1 into F2, right? Next, voltage magnification at resonance. At resonance, voltage across inductor and capacitor is going to magnify. It is going to increase. It is going to increase by how many times, sir? By Q times it is going to increase. Yes, it is going to increase by Q times. Q into V supply. Q into what? V supply. Okay, so that is one of the very important table, right? Now this is also one of the very important table, right? Active power or real power is equal to P is equal to VI cos phi is the formula. Reactive power is VI sin phi. Its units are watts. This units are watts. Okay, apparent power is VI is equal to root of P square plus Q square. If you wanted its magnitude, right? Magnitude we are taking mod V into mod I, right? Mod I, root of P square plus Q square. Why? Because S is equal to P plus JQ, man. S is equal to P plus JQ. If I wanted its magnitude, in fact that is equal to V into I conjugate. Conjugate means you know it very well. If angle is 30 degrees, we have to take it as minus 30 degrees. Root of P square plus Q square is equal to mod V into mod I, right? Now power factor cos phi is equal to cos phi is equal to R by magnitude of the Z, right? So complex power S is equal to VI conjugate, where I is the complex conjugate, which is equal to P plus JQ, please, which is equal to P plus JQ. Its units are volt amperes. Power factor is not going to have any units. The reason is this is in watts, this is in volt amperes. Both are power by power, no units. Resistance are R by Z, ohm by Z is also in ohms, therefore no units, right? Now this is for three-phase connection. I think three-phase is not required for you guys, right? So these are some practice questions I taken. These are some practice questions on the same concept I taken. Let's do that practice. Okay, let's do this practice. What is saying, an alternating current is given by I of t is equal to 10 sine 314t. The RMS value of the current is, this is damn simple. I RMS is equal to I maximum. You have to compare this one with this. I of t is equal to I m sine omega t, right? 10 divided by root 2, that is 7.07 amp. 7.07 amperes, right? Option is going to be B for Bombay, right? A sinusoidal voltage has maximum value of 200. Its average value over 1/2 cycle is, yes, we learned the formula for V average is equal to 2 Vm by pi. Just now we taken 2 Vm by pi. I given you the formula also to do it, but mathematics I did not done. Just making the average integration divided by time of 2 pi into how much is Vm. That fellow given himself has 200. That is 400 by pi. 400 by pi. If you calculate it, you will get it as 127.3 volts. Right? Option is C. Next question. The form factor of a pure sinusoidal alternating quantity is, see, for any sinusoidal alternating quantity, form factor is 1.11. What is the form factor formula? Vrms or Irms by V average or I average, which is equal to 1.11. It may be sine or cosine. See, you can remember this. Instead of doing all this, you can remember this. You can remember this. You know, see, you may be thinking, sir, you taken very simple questions. The questions are very simple. The reason is we discussed its concept and formula just before we were heading to this topic. Before we were entering into this topic, we learned all the formulas and all, right? Let's go to the next question. The peak factor or crest factor is how much? What is the formula? V maximum by Vrms. V maximum is Vm by Vrms is Vm by root 2. It may be current also, that's not an issue. 1.414, 1.414. This is also ready-made answer. Ready-made answer. In a purely inductive AC circuit, the current lags the voltage by 90 degrees. Yes, this is voltage, this is current, right? How much this is? 90 degrees. So previous questions we are able to solve very easily, and practice questions also. Means once you learn concept in right direction, it's going to be damn easy for you, right? A series RL circuit has R is equal to 8, XL is equal to 6 connected across a 100 volts AC supply. The current drawn and the phase angle are very simple. There is some voltage source, alternating voltage source, series RL. Right, this is R, which is equal to 6 ohms. This is 8 ohms, please. This is 8 ohms. So this is JXL, which is equal to J8, and this is 100 volts. This is 100 volts. Sir, this is 100 volts. We did not mention with as maximum value or average value or RMS value. If nothing has been mentioned, we will take it as RMS value. Now, he is asking about the current. Current I of t is equal to, yes, Im. Right, into, or this way, current is equal to voltage divided by impedance, right? What is the voltage? 100. RMS into root 2 will be maximum value. IF, see, I of t is equal to, I am writing the formula here, I of t is equal to Vm sine omega t by Z. Vm sine omega t by Z. Vm sine of omega t divided by Z. What is Z? Z is equal to R plus J X. Right, now I of t is equal to 100 into root 2 divided by root of 8 square is 64, 6 square is 36, right, into sine omega t, that is the magnitude. But every complex number is going to have angle also. What is that? Tan inverse of imaginary is 6 by real is 8. Yes, am I correct with respect to numbers? Yes, 6 and 8. Now I of t is equal to 100 by 10 into root 2, and sine of this is omega t minus, when this angle comes to upside, that is going to be minus 36. Actually, this tan inverse of 6 by 8 will be 36, I guess, right? So this is going to be minus 36.86 or 87 degrees. This is at 10. So RMS value of current is 10 because 10 root 2 is the maximum value, RMS value is 10, and phase angle difference is minus 36.86. 36.86. Option is B for Bombay. Why it is lagging, sir? Current lags the voltage. So this is V, this is some current I. Yes, sir. How much is this angle? This angle is 36.86 degrees. Option is B, right? Next, a series RC circuit. Yes, a series RC circuit has R is equal to 6, X is equal to 8 applied across the impedance and the nature of the phase angle. So impedance Z is equal to R minus JX r minus jxc, which is equal to 6 minus j8. He is expecting the magnitude. Root of 6 square is 36, 8 square is 64. Numbers, simple numbers I take, and the reason being is you will be not allowed you to use any calculator, so that here in the classroom also it will become easy for you to learn. Right now, phase angle phi is equal to tan inverse of imaginary part is minus 8 divided by 6. So this is going to be minus 53.13. Impedance angle phi is equal to impedance angle. Then current is going to lead. Current is going to lead. What is the current formula? IRMS is equal to PRMS is 50 divided by 10. How much it is? 5 amperes. 5 amperes of current. Yes, in capacitor, current is going to lead the voltage by some angle, right? By why it is not exactly 90 degrees, sir? If it is pure capacitor, 90 degrees, but as it is RC network, this is 53.13 degree. As it is RC network, it is going to lead, right? I think the solution here, it is given wrong. Okay, options are given wrong. This is 5 amp. 5, okay. No, correct only. He asked for the impedance 10 ohm. Impedance is 10 ohm with an angle of 53.13. Yes, 10 ohm. Current leads. Option is A, not B. Current is going to lead. That's why, see, options are framed beautifully. In the very first instant, we'll get confused. Options are framed very beautifully. Observe it carefully, please. Next question. A series RLC circuit R, XL, XC given. The impedance of the circuit and its nature is. What does it mean by nature? Something new added here. What is Z? Z is equal to R plus J XL minus XC or XC minus XL, whatever it is. Z is equal to 6 plus J, 16 minus 8. So Z is equal to 6 plus J8. Right? Magnitude of the Z is equal to root of 36. 6 square plus 8 square, that is equal to 10 ohm, right? So the nature is here XC is greater than XL. XC is greater than, XL is greater than XC. XL is greater than XC. Now the circuit is going to behave like RL nature. If XC is greater than XL, it behaves like RC nature. RL nature and RC nature, right? So it's going to be 10 ohm. It's going to be 10 ohm and inductive in nature. Why? XL is greater than XC. To remember, XL is greater than XC, it is going to behave like RL nature, right? Next. A series circuit has L is equal to 0.1 and capacitance is equal to 10 microfarad. The resonant frequency of the circuit approximately is FR is equal to 1 by 2 pi under root of L is 0.1. C is 10 into 10 to the power of minus 6. If you solve this, you will be getting. Yes, 159.15. I did not solve it. Solution part, just numerical calculation. I am leaving it to you. It is very simple here. And if you want 10 to the power of minus 6, right? Means 10 to the power of minus 7. If you take this 0.1 also into consider, this 2 gone. So 10 to the power of minus 3 means when it goes to upside 10 cube by 2 pi, 1000 by 2, 500 by 3.14, right? So from options it is not 50. Why? Because 3 into 50 is not going to 500. 100 it is also not correct. 300 is not correct. Why? Because it is going to be more than 900. So option is C. So this is how beautifully from options without calculator also we can solve this problem, right? Let's go to the next question. For the series RLC circuit of the previous question, if R is equal to 10, and the quality factor at resonance is Q is equal to direct formula 1 by R, 1 by 10 into under root of L. How much is L given by him? 0.1 by 10 to the power of minus 6, right? 1 by 10 into under root of, when it goes to upside, it is going to become 10 to the power of plus 6. So 10 to the power of 5 it is going to be under root of 10 to the power of 5 divided by anywhere we did wrong, 1 by R into under root of L by C, right? Yes, L by C. QR is equal to right? C how much given? 10 microfarads. 1 microfarad. 10 to, okay, 10 microfarads. Yes, 10 microfarads. Here 10 should be there. Here 10 should be there, right? Now when it goes to upside, 10 to the power of 4 it is going to be, to the best of my knowledge, right? 10 to the power of minus 5, 10 to the power of 5 into 0.1, 10 to the power of 4. 10 to the power of 4 means 100 divided by 10. This quality factor is 10 and no units. Quality factor, yes, literally not going to have any units. If you see, the kind of questions asked are very simple. Once you learn the concepts in right direction, yes, once you learn the concepts in right direction, yes, everything is going to be clear. Here I given three tables which are like very very important tables for this AC. If you understand, if you remember the data of all these three tables, right, along with the basics, right, that this is going to be AC analysis, alternating current analysis is going to be damn easy for you for your examination. Most of the students will find difficulty in understanding this topic, but this topic is very very easy. See, YourPedia is the only best platform in India offering a very good training for this kind of examinations. We started a dedicated live batch, yes, from 27th onwards. That is 27th onwards we started it. If you are seriously preparing for this examination or the next upcoming ATC examination, AAI ATC, it is going to have at least 400 vacancies, AAI ATC. Okay, so if you are seriously preparing, now this is the right time to start. You can join our module. It is a full module. Complete concept will be explained and lot of questions practice will be done for you, right? All the best. If you have any questions, you can talk to us using the number that is given in the description box. You can join our free WhatsApp group to get this free content, right? All the best.